so let's start with the warm-up. So I told you to draw a triangle like this, label all of the different parts, okay? So it says that x to z is 10. So x to z is 10. Oh, one frozen at the end. Okay, and then we've got y to z. Y to z is 7. And then we would label the angle here, which would be angle z, because that's the one in the middle, would be 115. Okay, so that's what your picture should look like. And I said I didn't care if it was right. Obviously, that's not a 115-degree angle, right? So picture not drawn right, that's fine. But I ask you to look at the vocabulary. What vocabulary tells us whether or not this is a unique triangle? So you had to look back at this slide. Okay, what is the vocabulary from yesterday? Cooper. Very good. Which one of these does this picture go with? Very good. Very good. You're the first class to get that today. Very good. So this is a unique triangle because of this SAS, because this is a side with an angle and another side. Who remembers what we called this when it's inside of those two? Good guess. It was like a friend. I said you were what within the group? Included. That's an included angle. That angle's included. So this makes a unique triangle because of that. Does that make sense? Do you have questions on that? Yes.
What's the difference between SAS and SSA?
We have not learned an SSA. Yes, we're not there yet. Yes. Oh, see, that's no. See, that's a no. That's a made-up one. Can't do that.
Would it just be two sides of an angle?
Yeah, see, see, two side links and non-included angle. Yeah, that's not a real thing. That's why I even tried to cover it up. It's not even a real thing. Yeah, it's just those two. Okay, questions, Kari?
Wouldn't SSS have an angle in them too?
No, SSS is only talking about the sides. So that's the one yesterday where I said if you built a prop and I gave you 3 pieces of wood,
We would all build the same thing.
all build the exact same thing. Yep. So if I go to a builder and I say, hey, I want this in the corner of my house, and I give him all 3, he's not going to mess it up. He's going to have the right thing there. Okay? Or if I say, hey, builder, I want this to be 10, I want this angle, and I want this to be 7, every builder will do it right because I have an included angle. Okay? All right, very good. Well, if he messes that up. But if I tell him his measurements, it will be right. Okay. All right, very good. You've done the best on that so far. Okay, second one. So this triangle would be QRS. So QRS. And if I say to make this 15 and R to S make it 10 and S to Q make it 5. Okay, is this a unique triangle? Yes. Yes. Why is it unique based on what we talked about yesterday? Yes, what's that called? That's the easy one. Yeah. What's this right here, right? SSS. It's side, side, side. I mean, it's not even like hard words. Like it's side, side, side. All the sides are the same. So yes, that's the one that we just talked about. If I give you 3 links of wood, everyone would have the exact same triangle. Every time. Okay? All right, last one. Your friend says that he can draw a unique triangle as long as he knows at least 2 sides and an angle. So if I just say, hey, I want a side of 12 and a side of 15 and give me a 90-degree angle, does that mean that all of ours would be the same?
No.
Why? Good. Why?
Because they don't have all the coordinates.
What do you have to have?
Side angles.
An included angle. You have to have an included angle. You can't just have a random angle. No random angle. Okay? Kari.
So, like, on the drawing thing, digits, do you have for the...
Okay, so again, review from yesterday. To create a unique triangle, you have 2 things. All 3 side links are the same. So I say make it a 3, 4, 5. Everybody would have the same one. Or I can use what we like to call SAS, even though that's not really SAS. It's just fun to say. Side angle, side, but the angle has to be included between these 2. It cannot be an excluded angle, which is what this says. This is saying you can make more than 1 triangle if 2 side links and a non-included angle measure, except in certain cases. I don't care about that. Okay? Any questions on that from yesterday before I add 1 more to it? Okay, let's add 1 more to it. All right, so today, let's look at the next slide. And the next slide says, can you form unique triangles if I give you 3 angles? And this is a little deceiving. So let's look at, and I'm going to have to slide this in and out. Okay, so look at this triangle. Do you agree that it has the same angle measure?
Yes.
Yes, see there's 60, 60, 60. But are those 2 triangles unique?
Because one's bigger than the other.
Oh my gosh, smartest answer of all day. Yes, one is bigger than the other. All day long the kids have not understood. They have to be the same to be unique, right? Exactly the same. Those 2 are not exactly the same.
Like twins.
They have to be twins. Very good. Okay. Earlier what I told them today is probably most of you have a bike somewhere. Okay. Your bike is not the same size as my kids' bikes, right? Because my kids are in 1st grade. If you have a 1st grader's bike, sorry. Okay. You probably look like a giant riding it. But your bike would look similar to my kid's bike, but it's not the same. Okay. It has to be exactly the same. And those are not the same. Okay. Let's look at another one. Okay, what if I told you the angles were 30, 100, and 50? Could you make a unique triangle? No.
Because you can make one that's bigger than the
I could make it much bigger than the other one. Would the angles still be the same? Yeah, I could still take this one and slide it over. See, that is still a 30-degree angle. This is still a 100-degree angle. This is still a 50-degree angle. But no, those 2 triangles are different sizes. Every single one of us could make a different size triangle. That would not be unique. Okay, that would not work. Very good. Okay, so here's kind of what this is saying. This is saying you have, these are 2 acute triangles. They're not unique. I can't have the same angles. Here's 2 obtuse. They're not unique. They're different sizes. That does not work. Okay, so that's the first one. Second one. This one says, a company sells triangle-shaped pennants. Do you guys know what a pennant is? Like a Royals pennant, like I think Miss Fadre has. It's like a triangle banner, like sign you put on the wall.
Oh, yeah.
That's a pennant. Okay. All right. For a school sports team, they provide the manufacturer with the following information for making the pennants. 2 angles measure 65, and their included side is 12. Is this enough information to be sure all pennants are the same? Okay. So let's look at what that's saying. That is saying that if you have, let's pretend that this one is 65. And this one is 65. Okay, can you tell me which side would be included? Which side is included? Marilyn? AB, perfect. You guys are the first class to get that today. This is the included side because this is a friend, this is a friend. This side is between the 2 friends. That's included, okay?
How are they not understanding?
I don't know, but I'm so happy with you guys right now. So very happy. Okay. So this is like the opposite of yesterday, right? Yesterday was a side, and an angle. Today is an angle, and a side, okay? All right, so what my question is this unique? And you guys think it probably is. So all I would have to do is take a look at this shape right here. And, whoops, maybe. And pull this shape over here. Does this match?
No. Yeah.
Well, I mean, pretend I'm perfect. Yeah, there you go. Does this one match?
Yeah.
Is this unique? Yep. See how I can pull that here? Is this one unique?
Yes.
Yes.
They're all
They're all unique. They're all the same shape. They've just been turned and flipped and stuff. That's what a kid told me yesterday. That was my favorite answer. Yeah, and stuff. And I was like, yes, turned and flipped and stuff. That's exactly right. Okay? So what that is called angle, side, angle. So angle, side, angle. This is the last one we're going to talk about. Which means if you have, here's your 2 angles, right here and right here. Here is the included side. If that happens, they're always going to be the same. They're always going to be unique if you have that situation. Okay? All right. So here's the only part of this that's a little tricky. So with this, okay, here's the thing. This is the part you really got to think about what I'm saying. Okay. Let's pretend that I said this angle right here is 30. What is this angle? 30, right? They're the same because of the tick marks. Okay. What if I say this angle is 60? What's this angle? 60. Okay. What is 30 plus 60? 90. How much would this angle be? 90. Another 90 because all triangles are how much?
180. So it'd be 100.
All triangles are 180. So anytime I really give you 2 angles, can you always find the third angle?
Yeah.
And if these 2 angles are the same, is that third angle always going to be the same?
Yeah.
It is. Okay. So basically, anytime I give you 2 angles and a side, whether it's included or not included, it's going to give you a triangle that's unique. Does that make sense? So you can call it ASA, or you can call it anything you want, but anytime I give you two angles and a side, you're going to have a unique triangle. What if I give you two sides and an angle? If I give you two sides and an angle?
You can't say everything.
Okay, so two angles, one side, yes. Two sides, one angle, no, it has to be this. Okay, that's what's confusing. Okay, but guess what? I have that all written on this last slide for you. So basically everything I've taught in the last 2 days is in this PowerPoint. Everything that's confusing is in this PowerPoint. Okay, so here's the wrap up for today. For a unique triangle, okay, all unique triangles, you can have two angles and an included side. You can have two angles and a non-included side. So just remember, if you have two angles and a side, you can always form unique, always, okay? But if you have three angle measures, what happened with the three angle measures?
They will not always the same. You can change the size.
Right, you can change the size of them, okay? That's everything from today. Everything from yesterday is back on slide 3, maybe, I promise, right here. And this is everything from yesterday, right?
Yeah.
Okay, so this is all side lengths. Yes. What about all angles? No. All side lengths? Yes. All angles? No. Okay. Two sides, and an angle. Only if what?
Only if
Oh,
it's
included.
Only if it's included. What about two angles and a side?
Yes.
Two angles
Yeah.
and a side.
Yeah.
If you have two angles, you always can have the third angle, right? So two angles and a side, yes. See, that's confusing. But it's all in this PowerPoint, okay? All right, so here's what you're going to do next. You're going to go through and make sure that 12.2 is done correctly. Meaning you need to make sure that you have the side measurements in there, and more importantly, Haley, the angle measures. A lot of you forgot the angle measures. You need to make sure that you answer the two questions. You should have been typing on two of them where the highlighted box was.
Yeah, I don't understand.
When you type that, it should be related to this. This is your reasoning. Not because I think so, not because they look the same, but you should be saying, is it side, side, side? Is it side, angle, side? That's what your reasoning should be. Does that make sense?
I get it.
Then your worksheet for today, after you know that your worksheet from yesterday is good, then you can start on that one. Here's what I'm going to do. As I grade them, if it's done correctly, I will put in a 2. If it's not done correctly, I will put in a 0. Because this is more difficult in your learning, I will give you until next Thursday at the end of the quarter. If it's not done correct by then, it's going to say a 0. But if it's done correct by then, I'll give you full credit even though it's technically late. Because I'm trying to give you some extra time. Come ask me for help if you don't understand what you're doing. Okay? All right.